probably a better way that you guys know about, but that's all right. Okay, so I don't think anybody had any questions. If you do have any questions, let me know. Slope and talking about lines is kind of a fundamental algebra topic. So again, one of those things, I don't like to say this a lot, but it's one of those things like what is a function is on a lot of standardized testing. The idea of slope and linear equations is also kind of one of those fundamental concepts that if you take any type of math beyond Algebra II, college math, you're probably going to run into this again. So it's worth spending a little bit of time on. Okay, so today we're going to talk about 2.3, which is called graphing. Graphing is pretty straightforward, but what we really want to talk about is make sure that everybody is on the same page, is what is a linear equation? And a linear equation is just the equation of a line, linear line, right? And it's always in the form of, well, not always. One of the easiest ways, you can have it in any form. Let me erase that like the last 30 seconds. It can be in lots of different formats. The equation of a linear equation can be in different formats, but kind of the standard equation that's used fairly often is y equals mx plus b. So that's right here on the top of your notes. Y equals mx plus b. I think we talked a little bit about this on Monday, and my whiteboard doesn't want to work. I'm having technical difficulties today. Sorry, guys. Anyway, right here, y equals mx plus b. So m represents our slope, right? We spent a lot of time in 2.2 talking about what slope is. X is what you're changing. That's your input. If we talked about in functions, that's what you're putting in, right? And then b represents the y-intercept. And the y-intercept just simply means where does your line hit the y-axis? Okay, have you guys all seen this before? It's in there somewhere. So quiet today. Okay. So the b is the y-intercept, and that's where it hits the y-axis. That can be written different ways, but we call this, well, we call this a slope-intercept form, is what it's called, because it tells you what the slope is and it tells you what the y-intercept is. One trick to know if something is a linear equation or not is it kind of has two telltale signs of what the equation you're looking at is a linear equation or not. The first one is that your x, I don't know why I can't draw today. I'll just draw this way. So the two signs that you have a linear equation is, one is that your x is only raised to an exponent of 1. So, we don't even write x to the first power, we just leave it as x. But as soon as you have in your equation an x squared, an x cubed, x to the fourth, x to anything, x to the 1/2 power, x square root of x, absolute value of x, then it no longer becomes a linear equation. So the single x, you could have more than one, but that single variable x tells you that it's a linear equation. Anything else, you're going to get something else. You're not going to get a line. You're not going to get a linear equation. The other thing that's kind of a telltale that it's a linear equation is that we don't have more than one variable. It might not always be x. I mean, in algebra, it's probably going to be x. But if you had y equals, let's see if my pen will work now. Oh, good. Y equals 3x plus t. This may or may not be a linear equation depending on what t is. Whoa, something, my pen went weird there. Okay, so is that making sense? Bunch of talking right when you wake up. Is it going in your brains anywhere? You guys still with me? Got it? All right, good. James is awake this morning. Yeah, all right, good. All right, Greta's up. I'm just teasing you guys. I know you're listening. Okay, so what we're going to do is basically we're going to graph a bunch of different things and we're going to look and see what do they look like and kind of just talk about it. You're alive. I'm glad that you're alive, Greta. Okay, we're going to just see what do they look like. So this is just to get a feel of like what the equation looks like on a graph. So again, not hard to do, but just kind of keep your mind open and we'll talk about it. So the first thing is graph y equals x, y equals 3x, and y equals x plus 4 and compare. Okay, so y equals x is one of those graphs you should be able to do without a graphing calculator, easy peasy, because y equals x, right? So that means when x, I'm gonna have a little graph here, right? When x equals 2, y equals 2. Totally just failed. Y equals 2 right there. When x equals 4, equals 6, y equals 6. And when x equals negative 6, y equals negative 6. So if we connect the dots, which I'm so great at on the computer. Nope. Sorry, computer issues today. If I connect the dots, you should be able to get a graph of y equals x really easily. You can see it's a line. Its slope is whatever is before the number before x, which is 1. So this has a slope of 1. It rises 1, runs 1, right? And it is increasing. It's positive. Okay, so that's pretty easy. Y equals 3x should be pretty easy to graph too. So this is something that you should be able to do even without your graphing calculator. So if y equals 3x, what you can do, so let's graph y equals 3x, right? So then you just pick a couple x's. So let's say first when x equals 1, what does y equal? 1 times 3 is 3. So when x equals 1, y equals 3. Right here, right? And then let's pick when x equals 2. You can see this is just like a quick, easy method. When x equals 2, y equals 3 times 2, which is 6. Right here, right? And let's be crazy and let's do a negative one. Let's do when y equals when x equals negative 2. So when x equals negative 2, 3 times negative 2 is negative 6. So that's down here. See if I can graph my line. That's lovely, isn't it? It's totally a straight line. Beautiful, I know. So this is y equals 3x. So what do you notice about the two equations? So we have y equals 3x and we have y equals x are the two that we've graphed. Well, the blue equation, y equals x, has a slope of 1, right? And the purple equation has a slope of 3. And so what happens when your slope goes up? The line rises much faster, right? Your rise over your run is much bigger. So even a difference of slope from 1 to 3, you can see how much faster this line increases. Amazing, right? So then let's talk about y equals x plus 4. Okay, so we have our base of y equals x. We tried varying the slope by making the slope 3 instead of 1. So that was y equals 3x. Well, let's stick with our basic y equals x, but then add 4 and see what happens to our graph. Okay, so again, pretty easy to do. Say, okay, well, when x equals 0, because I always like when x equals 0, right? When x equals 0, that means y equals 0 plus 4, which is 4. So that's one of my points. X equals 0, y equals 4. Right up here. Okay. What about when x equals 2? 2 plus 4 is 6. So when x equals 2, y equals 6. All right. And then let's do a -1. X equals -4. So when x equals -4, -4 plus +4 is 0. Y equals 0. Now when x equals -4, y equals 0. If I can get my cursor to work here. There we go. All right, so again, connect the dots. Let's try to connect the dots. Make yours prettier than mine. Okay, so now we have this green equation, this y equals x plus 4, right? What do you notice about the green equation compared to the others? Well, really, we want to look at the green and the blue, all right? They kind of look like they're the same. So y equals x and y equals x plus 4 appear to be parallel lines to me by my amazing drawing. And on top of it, I know that y equals x plus 4, the slope is just whatever number is before x, which is 1. So the slope is 1, and amazingly, the blue slope was also 1. So that makes sense, right? Two lines are parallel if the slope's the same. But what else do I have going on? I have this plus 4. So how does the plus 4 transform my simple y equals x equation? Well, the plus 4 shifted my whole line up 4 spots. You see that? Before I was at 0, and now my intercept is at 4. So this is the y-intercept part. So again, I don't think any of this is difficult, but it's kind of understanding the concept behind it. So you can say, oh, okay, if I increase my slope, my line's going to rise faster. If I, add or subtract something, my line's going to shift up and down on the y-axis. All right, so that was the messy part of me graphing by hand to prove it. It's not difficult to graph by hand. You only need, you truly, to graph a line, you really just need 2 points. I always like to get 3 points because that means if I messed up on one of the other 2 points, at least there's something. Like if I graph something and I get my lines are like here, here, and here, like, okay, something went wrong, right? Okay, so we're going to switch over to the graphing calculator for the next part of this. So you don't have to be tortured by my line drawing. So I am going to use Desmos, which is right here. You can use your graphing calculator. Yay, Desmos. And Desmos, which would have been way more elegant to do that. I just wanted to do it by hand to show you that, yes, it's possible. See, there's nice y equals x. And then if I, yeah, if I say, oh, okay, well, y equals 3x, then you can see that it's increasing. One thing we didn't talk about is what happens when you go negative? What happens when your slope goes negative? So let's actually put that up on here. So again, when we talked, we've got a positive slope. So let's instead make this one negative. So when you get a negative slope, your slope is falling, right? It's the red one is our positive slope, so it's gaining at a rise and run of 1. It's all right, Greta. And the blue ones are negative slope, so it's falling, but it's falling at -1, 1. It's all good. All good. Okay, so same rules apply. So basically what we're going to do is we're going to graph some equations and we're going to kind of see what they look like. And one thing I wanted to mention is when you're doing your homework, you can use, if you print out graph paper, and I can send that out to you, if you print out graph paper, you can draw like more than one on a graph. I wouldn't draw like all of your homework on one graph because that would be really confusing. But if you want to pick like 3 or 4 problems in a row and graph them on the same equation, that's not a bad thing. It actually kind of helps you see how the equation really affects what the graph looks like. Okay, so the first few things that I had for you to graph were, see if it will let me draw on here. Oh, good. Okay, so if we want to graph y equals x minus 2, we want to graph y equals 3, and we want to graph x equals 4. So we want to graph those 3 and see what they look like. So before we even graph y equals x minus 2, you can kind of quiz yourself like, do I think I know what this is going to look like? I know y equals x looks like this, right? And I have y equals x, but minus 2. So where do I think that this graph's going to be? So based off of this, I think my y-intercept is going to be at -2. And my whole graph is going to shift down to along here. Something like that. So then, of course, you can just plug it in your calculator. And then you can check yourself and see how smart you are, right? Oh, look at that. Why does that work? Well, because we could also write this as y equals x plus a -2. And remember, whatever is getting added is your b, which is your y-intercept. So it's intercepting at -2. Okay. All right, so what about, what if I graph y equals 3? That's kind of an interesting one. Y equals 3. What is my slope of y equals 3? Well, there's no x, right? So that means that if I really wanted to write this equation in slope-intercept form, I could write it as 0 times x plus 3. So if I have no slope, what does that mean? There's no rise over run, right? So y just always equals 3. Doesn't matter what x is. So I'm going to guess that my line's going to look something like this. Doesn't matter what x is. X is 0, y is 3. X is 5, y is 3. X is 1,000,000, y is 3. And you can check yourself, right? Y equals 3. Oh, look at it, even made it green for me. So again, when you're doing the homework, the point of the homework isn't just for me to see your pretty graphs. The point is for you to kind of check as you go to see, okay, do I have a feel for what these equations are going to look like when they graph? I'm glad that you're able to graph them, but the more important thing is understanding what do they mean. Everybody loves that, right? And the teacher says, I don't just want you to do it, I want you to understand it. Okay, what about x equals 4? We didn't really talk about this, and this really isn't in the y equals mx plus b, but this is another one that you should probably know how to graph, just kind of gut check. So if x equals 4, then what does y equal? Like when y equals 0, what does x equal? Well, x always equals 4 no matter what, right? So when y is 0, x equals 4. When y is 5, x equals 4. When y is -5, x equals 4. So I am guessing that my line is going to go along here. I'm not going to draw the whole thing because let's see what happens. Not y. You also have to make sure you type in right. X equals 4. There we go. So we get a nice vertical line when we graph x equals 4. So can anyone tell me what the slope of x equals 4 is? Undefined. That's right, James. It's undefined. We can't tell you what the slope is of this because it's it's run, basically how much it's changing in the x is 0, and we can't divide by 0. Nice, James. All right, we have 3 left to graph, and we're going to kind of do them. And as I'm doing them, kind of check yourself and say, could I graph this on my own? And then I'll let you guys get on with your day. All right. So we have, I know the notes are confusing on this. Let's try this one. We've got y equals 2x minus 1. Okay. Let's clear this off of here. So y equals 2x minus 1. Can I graph this without Desmos? Totally. You can totally do this. So this is already in slope-intercept form. So I know a couple things already, right? I know that my slope, I know that I keep hitting the wrong button. I know that my slope is 2, right? And I know that my y-intercept, and this is where you have to be careful because it's minus 1. So we can think of this as plus a negative 1. So I know that my y-intercept is negative 1. So just based off of those 2 pieces of information, you should be able to graph pretty easily. So my y-intercept is negative 1. So that just means, where do I hit the y-axis? Negative 1. Right here, right? And my slope is 2. So what does slope mean? We talked about this a ton, right? We could also write 2 as 2 over 1. And that's my change in y over my change in x. Okay, so I change positive 2y, I rise positive 2y, and then I run positive 1x. So positive 2y would be 1, 2. I'm going up here. And then positive 1 would be this way. So I should have a point right here. Okay, I go positive 2y, rise positive 2, run positive 1. Positive 2, positive 1. And then if I connect those dots, I would get a nice sloping line. So then we go and we say, okay, let's check and see, did we actually do that right? Yay, our points actually lined up, right? So that should be something that just based off the equation, you should be able to graph pretty quickly. And it makes sense, right? My slope is 2x, so it's positive. Yay, that's right. Positive, it's rising faster than, it's rising faster than just y equals x. And my y-intercept is at negative 1. Do you guys all think you could do that without a calculator? If you had to? You could make yourself do it? Probably. You could totally do it. Probably. I'm going to actually mix up example number. The notes aren't that great for this anyway, so you're probably not even following along. But I'm going to do E, but I'm going to mix E up a little bit. Of course. I like it, James. Of course you could do it, right? All right. We're going to mix up E a little bit by throwing a negative slope in there. Okay. So let's see if we could graph this guy example E without a calculator and then check ourselves. Okay. All right. First up, I have to figure out what the slope is and what the y-intercept is. So my slope is whatever is before x, so it's -3/2. And my y-intercept is 2, but it's -2, so it's actually -2, because I can think of this as plus a -2. Okay, so y-intercept is actually usually easier to start with. Y-intercept is at -2, so that is right here. Got that? Okay. This is what confuses people a little bit when they get to slope. So when you have a negative slope, how do we deal with that? How do we deal with that when we're actually going to graph? Well, you have a couple options. What you can do is you just choose to apply the negative to one, either the numerator or to the denominator. Okay, so I'm going to choose to say this is -3 over +2. You could, if you really wanted to, say that it's 3 over -2. You'll actually end up in the same spot, and I'll show that to you. So that means that I rise -3 and I run +2. So practically what that means is I rise -3. So if I'm rising -3, let's switch up the color so I can show my slope on here. I'm rising -3. This is my -3 rise. And that means I'm running +2. So my actual point, if I actually graphed it on the right spot, would be right here. Okay. What happens if I assigned, instead of -3/2, if I said, okay, it's going to be 3 over -2? How would that have worked out? Well, that would have meant that I rise +3, rise +3, 1, 2, 3, and I run -2. So I would have gotten my point right here. So I have a point here, here. So it works out either way that I go, you're going to end up with a different point that you've graphed, but you still get the same slope, whether you assign the negative to the numerator or the denominator. Okay, so then I would want to connect the dots going down this way. So to check, this is where you have to be careful using a graphing calculator. So if I typed in y equals -3 divided by 2x, and you get this crazy graph, which we will talk about these graphs, you just have to be careful because calculators are only as smart as what you put into them. You have to know what you're doing. So check and make sure that you don't accidentally put your x in the denominator. It has to be -3/2 times x, right? And then -2. So yay, it went through our points. Exciting, right? Way easier to do on the phone today than in class, though. Okay, last problem of the day. What happens if... Are there any questions so far? Are you guys all like, okay, yeah, we got it? No questions? All right, cool. I'm glad. This is just one of those fun, I know some of you might have spent a lot of time doing this in Algebra 1. This is just one of those kind of fundamental understandings of algebra. Okay, what happens if we throw up a equation like that? If we put out an equation like this, negative 6x plus 8y equals negative 36. Wah, wah. Can we all of a sudden use our slope-intercept form that we had that y equals mx plus b? Well, we can, but we can't use it with this form, right? We've got 8 times y, we've got x and y on the same side of the equation. We can't use the slope-intercept form to easily identify what the slope and the y-intercept are. We have to do some work to the equation to do that. In addition, for any of you that have TI 83-4 calculators, if you go to plug this equation into your calculator, you can't do it because the way a TI calculator is set up, when you go into graph, if you've done a lot of graphing, you have to write it at, there's a bunch of Y1, Y2s. You have to write into your TI calculator in Y equals something form. So if you go to try to graph negative 6x plus 8y equals negative 36 in your graphing calculator, it's not going to like it like that. So what we need to be able to do, and why we spent time in chapter 1 transforming equations, is we need to be able to rewrite this as y equals something. And that is a couple purposes. One, then we can use slope-intercept form. Two, we can graph it in a graphing calculator, TI 84 or whatever you have. Okay? So let's erase this off of there. So how do we get y by itself? Well, we use those same tools that we did back in chapter 1 to get y by itself. We need to send everything to the other side. So we need to get y, it wants to be lonely by itself, right? So the first thing we want to get rid of is this minus 6x. So let's add 6x to both sides. Okay, and we're left with 8y equals 6x minus 36. Okay, we're getting close, right? We have 8 times y equals 6x minus 36. So how do we get y by itself? We need to get rid of the 8. Okay, two ways that you can do it. One is you could divide both sides by 8. The other is that you could multiply both sides by the reciprocal of 8, which is 1 over 8. And they're going to end up doing the same thing. So I'm going to go ahead and divide both sides by 8. And I get y equals 6x divided by 8 minus 36 over 8. And those are all fractions that can be reduced. So I will get 3/4 x minus, I think this is going to be 9 over 2. Oops. 4, yep, 9 over 2. 4 can go into both 36 and 8. It's a nice looking equation, right? So one thing that you guys are really smart at is playing with technology. So since you heard me say that TI calculators will not graph in this format, you probably thought, well, does Desmos graph in this format? Well, it actually does. So I'm sure you guys will figure that out anyway. But one nice thing that you can do is if you do have access to Desmos is you can check and see, did I convert my equation the right way? So this was my original equation. And then I said, well, I could rewrite it as y equals 3/4 x minus 9 over 2. So what you see, with all this scratch over top of it here, I'll turn it off for a second, is that when I graph the two equations, they're the same line. So that means that I did a good job of changing to the slope-intercept form. You guys understand that? Okay. Also, I kind of jumped the gun, right? I went ahead and graphed it, but I should be able to graph this on my own. So let me hide that. Pull all my crazy writing back up here. Let's do a really, really, really quick graph of this. So my y-intercept is at -9/2. Well, that's -4.5. It's right down here. And my slope is 3/4. So that means that I rise 3. 1, 2, 3. This is my rise 3. And I run 4. 1, 2, 3, 4. So this is 4. And this is 3. Then I can rise another 3. 1, 2, 3. And run 4. 1, 2, 3, 4. Okay. So I've got my 3 and my 4 right here. So now I can turn my graph back on and see, did I line those up pretty well? All right. Any questions? Does it seem, how does it seem? Pretty straightforward. You've done it before. You think you could graph without a calculator if I made you? Seems pretty, yeah, that's what I said. It's not actually crazy difficult to do, but the important thing is understanding what you're doing. I know that you all can plug things into Desmos. I have complete faith that you guys can use all the technology you have out there, but it's really just understanding what you're actually doing. Okay. All right. So what I am going to have you do, it looks like a ton of homework. So let me double check what I have you doing. So I actually like a lot of these examples. So if you have your book, you can look with me. I'm on page 93. If not, I'll just kind of tell you here and I'll try to type this out. So what I'd like you to do is actually graph like 3, 5, and 7. I want you to put those all on one graph because you're comparing how the graph changes. So, you know, if you want to print out some graph paper, again, I'll send it out like the number line. Take one of the graphs and graph 3, 5, and 7 on there. And then yeah, so let me look at this. I'll send out an email in about 5 minutes with exactly which problems I want you to do and it's some graph paper. I am going to have you do fairly many because you can use a tool to help you, but I want you to kind of check yourself before you actually just plug everything in. Because again, I know that you can plug things in and get the answer out, but I just want you to be able to kind of think about what you're doing. So I might mix up the homework a little bit and I'll send out some graph paper. So give me about 5 or 10 minutes and I'll send that out to you guys. Does that sound all right? All right, sounds good. And homework isn't due until the end of the chapter, so you'll have, you know, some time next week to work on this as well. All right, well, thanks for listening to me today. Hope it was exciting graphing day. Have fun playing with Desmos. Yes, fun graphing, that's right. It's actually a really good class to be online for because if you had to sit there and watch me graph everything on the board, that would be painful. All right, well, you guys have a great weekend. Should be awesome weather. Enjoy whatever you're doing, and I will see you on Monday. Bye. Bye, James. Bye, Greta. Bye, Mackenzie. See you Monday. Bye, Daniel.